All right, good morning, everyone. Welcome to day 7, Friday, January 19th for the online AWD C# programming class at Rankin Technical College. Today, we're going to go over chapters 4 and 5 of the Murach text. We will spend probably the way I'm looking at it right now, and we'll see how it goes. Monday and Tuesday of next week, I'm looking at doing just a boatload of problems. And again, creating a pretest for you, etc., and doing that on Wednesday as well, and probably next Thursday, then having a test on chapters 4 and 5. We'll just see how it goes. All right. Now there are one person did drop from the class, so we have 16 in the class right now. All right. And as far as I know, I've gotten tests from about 3/4 of you, which means about a quarter of you did not turn in a test. And I'd really appreciate you getting it in as quickly as possible. You will lose points if you didn't have it in. All right. I'll just leave it at that. Okay. So remember your completed chapters 1 through 3 homework and the chapters 1 through 3 written tests are due by midnight this Sunday. All right. In a week from Sunday will be the same stuff for 4 and 5. So let's just get started here. And chapter 4, which starts in your book on page 91, and it's on how to work with numeric and string data. What you will find, will there be new things in this chapter? Yes. Will there be new things in chapter 5? Yes. But some of the stuff in each of the chapters I've already talked about. All right. So I'm not going to spend a boatload of time going over and rehashing things we've already done. It doesn't mean I won't talk about them. All right. But we're going to concentrate more on the things that are new. So we'll talk about the built-in data types in C#, some of the special stuff you can do with strings, how to convert from one data type to another, and then as you can see, scope, enumerations, a lot about nulls. And then we look at 2 versions of the invoice total app. Now, I'm not going to go there right now, but what you're going to find is the enhanced version that they talk about is very similar to the enhanced payroll thing that we did in class the other day. In other words, what they're going to add onto here for their enhancement is they're going to have the total number of invoices there were, the average invoice price, all right, and the total of all invoices, very similar to what we did with the employees, all right? Okay. So what you're going to notice on the next page when I get there in a second, that C# has a lot of different data types. All right. Notice as it says here, the first 8 that they're going to show on the next page all store integers, which are whole numbers. All right. And there's different ways of doing it. I will tell you that probably well over 90% of the time, out of these 8 types, you'll only use one, and that'll be of data type int. That doesn't mean that you can't use the rest or that there's anything wrong with the rest. It just means that's pretty much the way that it is. All right. The next 3 that they will talk about are double, float, and decimal. Those are all data types which can potentially have a decimal point in them. All right. I tend to use decimal most of the time, float almost never. And there's reasons for that. It doesn't really pay to go over it with you. All right. They do mention on the bottom of the page that C# supports the Unicode character set. Why is that important? Well, back when I was learning this stuff, so back when I was your age, we used the ASCII character set. ASCII is an acronym, American Standard Code for Information Interchange. Well, at the time, we weren't the international global type of society we are right now. So really, that character set had only 256 characters in it. It had upper and lowercase characters, and that's 52 of them right there. All right, so about 20%. It had your special characters, a comma, an asterisk, etc. But over time, that wasn't big enough. So we went to the Unicode character set, which started off with about, I think it had about 65,000 different characters, and now I believe it's over 100,000. It basically has characters for every language that's out there, and it even has room for growth. All right. Finally, the last type is Boolean, which we've talked about. All right, which can hold true or false. I do want to mention, you may or may not be able to hear this. I am at the Rankin-Wentzville campus. Now, when I go to the Rankin-Wentzville campus, 99% of the time, there's only 2 or 3 people on the end of the building that I'm in, and it's very quiet. Today, they're having a breakfast for employers in the area. So there's about 30 or 40 people here. The reason I'm mentioning that to you is I have been told by our vice president that they may be coming in, and if they do, give them a little 5 or 10-minute speech about what the program's about. So if I have to stop in the middle of mainstream, I've got a couple projects up here, etc. All right. But then I'm going to show them and I'm going to talk about with them. All right. I don't know if it'll happen or not. They said they wanted to play it by ear, and they said maybe we won't stop over at all. But if they do, that's why. All right. So here are our built-in data types. Byte and S-byte, they're integers, but they have a smaller range. I've always been amazed, like when you do programs, for example, that involve people's ages. People don't use byte, all right, which would make sense, 0 to 255 for an age, as opposed to, 0 to 4 billion something if it's an unsigned, or negative 2 billion to positive 2 billion. But it's just the way it works. You'll notice that some of these say S and some of them say U. If it says S, that means it's signed. That means that it can hold both positive and negative values. If it has a U there, it's unsigned. So it'll only hold values from 0 up to a certain range. But as I mentioned, the int32 that's right here, which means it's a 32-byte integer. All right, that's typically big enough for anything we'd ever do in a class like this. All right, notice with a long, I can't even read that number to you because, whether it's a long or an unsigned long, I don't know how to pronounce that. All right, but it's big. Now, then notice you've got float, double, and decimal. All right, and basically the difference between float, double, and decimal is how much accuracy it has after the decimal point. All right. So notice that float has got 7 and double has got 14. All right. Then there's decimal, which typically I use a lot today because, as it says, it's a non-integer with up to 28 significant digits, and it can hold a really big number. All right. The other two that are there, you've got char, which is a single character. And I showed you an example of that the other day when we had the example and we said, did you want to run the program again? And we used a char. We asked the person to enter yes or Y or N, but then we just grabbed the first character in case they put in a yes instead of Y. All right, so char in this language must be in single quotes. Strings, which we'll talk about in a bit, must be in double quotes. The reason I bring that up is many of you who are watching this lecture live or on tape, all right, you know that when we were in the JavaScript class last semester, that in JavaScript, there is no such thing as a char. Everything is a string in there. So you can use either single or double quotes, not in this language. And again, bool is for Boolean, which is a true false. You can read about this more if you want to, all right? Some of it's a little historical in nature or whatever. All right, we've been using almost since day 1 in here, we've been using variables. And what's a variable? It's basically, really what it is it's a memory location. So it's a location someplace in the computer's memory, and the value of that's in there can vary as the program runs. All right, there's really 2 types of variables. I just mentioned to you the first type. All right. Then in this language, there's also constants. A constant is a variable, but it's a variable that once you've set it, all right, you cannot change it while the program's running. Okay. Then next they talk about variable declaration, and they talk about variable initialization. So again, there's declaring a variable, int counter. There's initializing a variable, counter equal 1. Yeah, it's an assignment statement, but it's an initialization. Here we're doing both. All right. The way that C# works is when you do not initialize numeric variables, they're initialized to 0 for you. All right. I still initialize almost everything anyway. When you get burnt, when you work as a programmer and the software doesn't do something it's supposed to do, it's on you. So I always initialize, or almost always initialize my variables. All right. When you work with char variables, okay, they're basically set, I think, to a blank space. So single quote, space, single quote. Booleans are set to false, and strings are set to the empty string. Now you'll notice in here, most people don't use floats because, like with a decimal, when you've got to use an M, when you use a float, you've got to put an F on the end, either an uppercase or a lowercase f. Just like with decimals, you need an uppercase or a lowercase m. Same kind of an idea. All right. So as it says, common initial values are 0 for variables that store numbers, 0.0 for decimal or float or double, false for Boolean variables. All right. Now they go through their conventions. Typically, you will use a camel notation. What that means is typically, all right, if I've got a variable named tax, it'll be like this. If it's tax rate, it'll either be like this or it'll be like this. Now, I prefer this method because that basically that method can be used in virtually any programming language that I know. Sometimes this one cannot be. All right. But this is called right here, this is called camel casing, because every time you add a new word, all right, the first letter of the new word, all right, the first letter is always capitalized. And they say that kind of looks like a camel with the humps on a camel. All right. Now, that's a variable. If I copy this, and this, I'm actually giving you something that we'll talk about in a week or two, but doing this now makes it a method. You do not have to capitalize methods. That's what is pretty much in vogue today. That's what Murach does in the book. That's what I've started doing. But the big thing is methods need to have parens after them. So I could write a method like this. It would be totally legal to do that. But if I left these off, the system would think I'm talking about a variable and not about a method. And all a method is it's a function. And all a function is it's some code that you write that ideally will do one thing. All right. All right. So constants, we've looked at these already. There's really nothing new in here except, all right, I do not agree with them. Now, the first programming language I learned and used when I was professionally programming was the C programming language, not C. I'm sorry, not C#, not another one called C++, but C. And in that language, where I worked, you were told you should take your constants and make the entire word uppercase so that it stands out. All right. The only difference between this and a variable with this name, a regular variable, is there's a capital D right there. But I think it makes more sense to capitalize the whole thing. All right. One thing you don't want to do, I have not looked at any of the tests yet, but if you are coming in here and you're writing code, I don't want you to do this. All right. And say int age. You shouldn't do that. Regular variables, non-constants, should always start with a lowercase letter. All right, why? It's the convention. So again, if I was going to do const int here, so let's say const int voting age equal 18, very similar to one of the examples we had in, not too long ago. I would put it all in uppercase, whereas the people from Murach would have said this. All right. Like I said, I wouldn't do that. Oh, I guess they would put the A capitalized too. All right. Sometimes what you do is a matter of taste too. I would tell you this, that if you say, you know what, I listened to what you said, I'm doing it the way I want to do it. Well, if you're going to do that, you're going to do that. The point is, come up with a standard and stick to that standard. Even a bad standard, a way of doing things, even a bad one is better than having no standard at all. All right. When you capitalize the first letter like this, it's called Pascal notation. And if you've never heard of it, Pascal is another programming language. Okay. All right. Then next, we're going to talk about arithmetic expressions. So let's look at them. I'm going to take for granted, you're all bright people. These first four in here make sense. All right. You know how to do addition. You know how to do subtraction. You know how to do multiplication. You know how to do division. Again, it's an asterisk for multiplication and a / for division. All right. The next one is modulo, which we have looked at already on a couple of our programs. It's the remainder operator. All right. Then you've got plus and minus, because you can preface any number with a plus sign or a minus sign. Then the last two are plus, plus, and minus, minus. We started to talk about this a little bit the other day, but I want to show you something quickly. All right. So let's say I create two variables, int a equals 27, int b, and I'm not going to give that a value. All right. Now I'm going to put in here dot, dot, dot. All that means is someplace later on in my program, somewhere later in my program, now I want to assign B. There's a difference between saying this and this. They're going to give you different values for B. This right here is called the, I'm going to move that over. This is called the pre-increment operator. And this is called the post increment operator. What does that mean? That means what this does right here, this line, is the same thing as if you went in and did this. A equals A plus 1, B equals A. So when you get done with this one right here, all right, assuming we haven't changed the value of A, then A and B equal 28, because we've added 1 to A, so 27 plus 1 is 28, and then we assign A to B, all right? Now, this one is the post-increment operator, so it is like we did this. B equals A equals A plus 1. So when we get done here, when we're done, all right, B equals 27 and A equals 28. So you can see the difference, hopefully, between those when you look at it. Now, I've had people in the past who have said to me, I find that really, really confusing. And my comment to them is, then don't use it. It's totally legit. You can make your programs work without doing it. Not only that, we're going to look at this in just a minute. There is a shortcut, remember, here for this too. You can say A plus equal 1. Now you could put any number here, any number. I could add 37 to A if I wanted to. 56, 112, it doesn't matter. But when you are working with plus plus, whether it's before a variable or after a variable, that will only allow you to add 1 to the variable. And not only is there a plus plus, there's a minus minus, which will decrement a variable by 1. Now, most of the time when you use this, it'll be something like this. For int LCV equals 1, LCV less than or equal to 100, plus plus LCV. What that'll do, and we're going to get into this later today, this will loop through something 100 times. That's most often when you're going to use the plus plus. And there it does not matter a lick whether you put it here or whether you put it here. And again, you can say LCV equals LCV plus 1, or you can say LCV plus equal 1. Those all work. Most people, I've said this before, it's not funny. I don't think this is funny at all, but I've never known anyone who got into programming. And I said, why'd you get into programming? They said, because I really like to type. That doesn't make a lot of sense to me. But there's different ways of doing the same thing. And that's what I'm telling you here. And they've got a whole page full of different examples here. All right, where they show you different mathematical operations and the results of those operations. The first 5, as it mentions, are binary. That means it needs these 5 right here, all right, all the way through modulus. They need a number before it and a number after it. These 2, in fact, the other 4, these are unary. You don't need a number before it and a number after it. You only need a number or a variable. All right. Now, this was that assignment statement that I just mentioned to you. And you'll notice that there are 5 of them. Plus equals for addition, minus equals for subtraction, times equals for multiplication, divide equal for division, and modulo equal for modulus. Now, the first one that's up there is assignment. It used to be, it isn't like this anymore, but it used to be in most programming languages, if you wrote this, B equal 10, C equal 12. And if you wrote if B equals C, like that, that's wrong. But if you wrote it like that, in most programming languages in the past, it would always be considered true. Because what this says is it possible to take C and assign it to B? And it is possible to do it. It's not testing for equality. If you want to test for equality, you must put in 2 equal signs. Now, unlike JavaScript, for those of you who were in the class last fall, there is no triple equal sign here. There is no triple equal sign like there is in JavaScript. All right. The other thing too that they don't mention here is plus equal. It is addition, but it's more than that. What do I mean? Well, if I come in here and do this, I'm going to say, let's see, kind of a dumb example, but I'll use it anyway. I'm going to say string name equal, and I'm going to put Jeff with a space. And then, and I'll put F name here for first name. String L name equals Scott. String full equals, now I can say F name plus equal L name. The only reason I'm bringing that up to you, that is not addition. That is concatenation. I'm saying take this and add to the end of it this. So yes, plus equal almost always is used for addition, but it can also be used for concatenation. All right? All right. Now, the order of precedence, much of it is what you learned, or half of it at least, if not more, is what you learned back in, I think for me, it might have been 8th grade or something like that. I don't know, might have been, it was earlier. You do multiplication and division before you do addition and subtraction. Modulus is just another type of addition. I'm sorry, of division. Modulus is just another type of division. So you do multiplication, division, and modulus before you do addition and subtraction. This positive and negative is just making something positive or negative. This is the plus plus and the minus minus. So this is the order of precedence for these. If you want to change the natural order of precedence, you use parentheses. All right. The system always knows what it is you're trying to do, even if you don't know what you're trying to do. It's got to just follow the lead you give it. All right. So in other words, if I were to do something like this, all right, let's have three numbers. Int A equal 10. Int B equals 24. Int C equal 12. Something like that. There's nothing, no significance to these numbers. But if I say something like, all right, let total equal A plus B minus C times D divided by, I guess there was no D, divided by A, and then, I don't know, or times A divided by B. What's going to happen in this is it's going to do this first. C divided by A, 12 divided by 10. Since they're all integers, it'll throw away any remainder, and it'll be 1. Then it'll take the 1 next, the result of this, and it'll divide it by 24. All right, so it'll be 1/24th, whatever that is. Then it'll take A plus B, then it'll take the result of that, all right, and do this. Okay, it's a little confusing, but not really. And again, the idea is, if you want to change it, if you want to make sure that all of this happens first, I can put parens around here. Now it'll do A plus B, 10 plus 24, which is 34, minus 12, which will be 22. Then it'll multiply that by 10. So that'll be 220. And then it'll divide it by 24, which will be 9, basically. All right. And that's pretty much what they talk about it here. Again, I'm not reading this stuff. All right. Now, I want you to understand, we're going to go over this right now, but I want you to understand something about this first. All right. If I do this, let's say that A is 17 and B is 24, and I'll get rid of this. Now, let's say I do say int C equal, and I say B divided by A. It's going to give me an answer of 1. If I were to have said int D equals A divided by B, it's going to give me an answer of 0, because I'm doing only integer math. I'm only working with whole numbers. And since I'm only working with whole numbers, it throws away any remainder. All right. So this actually is like 1 and what? 1 and 7/17, whatever that is. Doesn't matter. But you don't get like a 1.4 or 1.3 something. It's just 1. This is 0 point something, like 0.69 or something. It throws away the decimal portion. What if I want to preserve that? Well, I could take any or all of these and make them decimal, or I could make them double, or I could make them float, or I could come in there and do this. I can do what's referred to as casting. When you cast, you must cast on the right-hand side of an equal sign, because this is working with copies of whatever is in A and whatever is in B. I can cast in one of three ways here. I can say here, for example, decimal, like that. Now I'm casting B. So what it's done is it has made B, instead of 24, it is now 24.0 M. All right, so it will retain now whatever value it had in there. So I can cast this, or I can cast this, same thing, or I can cast them both. It doesn't matter. But what you're doing when you're casting is you're taking a copy of your variable and you're casting it to a different variable type. All right. When you do that, and this is what they mention in here, you can get what's called a widening conversion, or you can get what's called a narrowing conversion. And I believe they show examples on the next page here. All right. So it says casting from a less precise to a more precise. All right. Now, if you look at the example here, this is a great example. It really is. Because we had what? Okay. We had 86 and 91. They're both ints. We've got A, which is 95.0. Since we've already got one double in there, all right, what will happen is there will be a widening conversion that takes place on B and C. It's as though we made B a double with 86.0. It's as though we made C as a double with 91.0, and it will work. On the other hand, again, had this been an int right here, had this said int A equal 95, and we did nothing else to this, even if we put double here, it would add an int plus an int plus an int and divide it by an int. Since it's all integer division, it would throw away the decimal portion. All right. Now, another thing you could have done here, in this case, to preserve this, is you could have said 3.0. That would have worked as well. So there's a lot of ways that you can cast, and they're showing you some of them here. All right. So it says if you code an assignment statement that assigns a less precise, all right, to a variable with a more precise, like I just showed you, that's a widening. If you go the other way, it's a narrowing. But you have to always realize you are not changing the value of any variable in the program. You are changing the value, I should say the data type of a copy of what's in that variable. All right. All right. C# has a math class, just like most programming languages have a math class. Again, if I go out to learn.microsoft.com and I put in here C# math class and hit enter, somewhere in here it's going to find it. All right, I don't know where it is, but it'll be in here. All right, I might have to look around for it or whatever. The point is, there are a bunch of different mathematical operations that you can perform. Now, one of the key things here is this sentence you see near the top. It says the 5 methods shown in this figure are static methods. What that means is, okay, you can call them directly from the math class by saying math dot or math period and the name of the method. They give the example here of rounding. Let's take a look on the next page here. Here are 5 static methods. 1, 2, 3, 4. Maybe I counted wrong, or maybe they did. But when you round, you can actually round in different ways. So if I put in here, for example, math.round, and let's say that the number I put in here, I put in 37.5 and nothing else, just math.round 37.5. Then the system looks at it and it says, oh, it's 0.5, so it's 1/2 or more. I will round that to whatever I said, 35. If it's 35.5, it'll be 36. If it's 35.4 and I do that, it'll throw away the 0.4. I can also tell it how many places I want it to round to. Typically, when you do that, it's again, you're using dollars and cents or whatever, and you want to round it to 2 decimal places. All right. Math.pow is how you do exponentiation. All right. So if I want to say that x is equal to y cubed, I'd say math.pow. All right. Or if I want to say x cubed, let's say math.pow x 3. Square root should be pretty easy to understand. And I did an example for you the other day of using min and max. All right. And they've got some here as well. All right. Now, when you look at these, I mean, one of the first things I thought was, okay, I get most of them, if not all of them, but they seem fairly simplistic. Isn't there a better way of doing some of this? Yes, that we'll find out in later chapters. All right. So you don't have to worry about it for right now. All right. Random numbers are popular, and they're popular because they're used a lot in games and things like that. All right. We're going to, when we get into chapter 8 in a few weeks, one of the programs we'll write together works with random numbers. C# is a little bit different, but virtually any random number program by default, which means unless it's told otherwise, any random number program does this right here, like next double. It returns a decimal value that's greater than or equal to 0, but it's less than 1. All right, so for instance, if it would return 0.8735, then the number you're typically going to get is going to be 87. If it's 0.8795, it'll return 88. All right. Unlike some other programming languages, C# has different instance methods that you can use for random. So this is the one, if we take a look at these examples right here, number.next is going to give you a number greater than or equal to 0, and then less than or equal to that 2 billion number I showed you before. That's not typically going to be what you want. All right. If you say number.next and just do it like this, all right, it'll give you a number between 0 and 100. Here's a number between 1 and 100. So if I was going to generate a bunch of random test scores, I would probably use this one right here. So it's possible for somebody to get a 0, and 100 would be the greatest number. All right. When we get to chapter 8 in a few weeks, we'll use the number.next here. You'll see it to generate a random number between 1 and 100. And you can do it with doubles as well. All right. They're working with die. So you're doing a pair of dice. And notice they both go 1 to 7, which is going to give you a number greater than or equal to 1, but less than 7. So a number between 1 and 6. It's kind of interesting because it's probably more than any of you care about. But when you look in there at this first bullet, it says that it's going to generate a series of random numbers. But notice it says they're pseudo-random. What that means is there actually is a pattern. So it might give you 510 random numbers and then repeat that pattern all over again. All right. Now, when you do this, if you noticed, that's kind of an important line right there. All right. When you do that, that is creating a new instance of the random number class called number. So it's of type random. And now I can call any of these things on it. All right, but this is called seeding the rand. Do you have to worry about that? No. But in case you hear the what I'm giving you here as far as, the names for it. All right. All right. Now we're going to switch here and go into strings. So again, if I go back and say C# string class. All right. And somewhere in here, they're going to have all the different stuff in here with strings. All right. There's a lot of different string methods that you can use in this language. All right. Notice what it says here. A string can consist of any letters, numbers, or characters, virtually anything on a keyboard. Strings must be enclosed in double quotes. You've already seen that you can assign an empty string to a variable by using double quote, or as I've mentioned to you before, you can put in string.empty. All right. A third thing that we're going to get to in just a little bit is you can assign null to a string. Null means unknown. All right. And when you do that, you oftentimes use this null forgiving operator. You're going to see examples of it in just a bit. All right. And again, people have said to me, okay, it means unknown. Isn't that just zero? Not at all. All right. So imagine that instead of watching this live, that we were in a classroom. All right. And Mary walks in one day and says, she walks in before class starts and says, good morning. I say good morning. We introduce ourselves to each other. And I say, somehow we get talking about GPAs. All right. And she says, well, I don't have a GPA yet because this is my first class. That means her GPA is null. It's not 0.0. She hasn't taken any classes yet. So null literally means unknown. All right. Okay. I already mentioned using the plus equal and to append strings together. So you've already seen that. All right. There's nothing new really right there. So they've got all sorts of examples. Here's initializing a string. Here's initializing a string to the empty string. Here's initializing a string to null with that null forgiving operator. That can be important using that null forgiven operator. The reason that it can be important, all right, is what you can use that not only with strings like this, but you can use it with other types of variables, even things that typically should not be null. All right. So they join strings together, strings and numbers, etc. All right. So there's plenty of examples in here. Okay. Now, I don't know if it's the next page or not. No. Okay, we're going to see something else about these in just a second. All right. How to include special characters in strings. May have mentioned this already, may not have. I don't know. Probably the first two in here are the two you're going to use 99.9% of the time. All right. But I'm actually going to show you an example in the future where we will use that \r. All right. So you will see that. It is possible for you to use that one as well. What I'm telling you is most of the time, the one or ones that you are going to be using are going to be those first two. The other thing I want to mention to you, and I may have said this before, I don't know, but is this. So if I come out here and say this, let's assume that what I want to do is I want to print my name on 2 lines. All right, so I want it to go like this. Okay, I'm just going to show you a few different ways of doing it. I could say right line. So let's say, again, just like before, we'll say string fname equals Jeff and string lname equals Scott. Oops. Just like that. And I want to print it again. So I want to print out this, Jeff Scott. Don't ask me why. It doesn't matter. All right. But that's what I want. I'm going to show you 3 ways you could do that. I could say right line, and I could just say, for example, F name, \n, L name. Now, when I do this, it's not going to like that. It's going to be confused. So I can fix that by either using string interpolation that we've been talking about, where we put in this, and now I can put in F name, L name like this. That'll work just fine. But that'll give me exactly what I just showed you. And I said that that's what you'd want. So it right up above there. So it would have Jeff, and then Scott like this. All right. But if I wanted to, I could also break this up and I could say right line. And I could say, for example, F name plus a new line plus L name. That'll work just as well also. All right. Or if I wanted to, don't ask me why I'd want to do it this way, but I could. All right. I could say right line F name and then say plus this, and then do another right line and say L name. That would work also. So what I've just shown you here, I'm going to get rid of these so I've got some room here. You can do it this way, you can do it this way, or you can do it this way. Finally, just to show you one last way, I'm going to copy this down, paste it in, and that is I could have gone and done this. Let's get rid of that. Let's take this. So that's at least 1, 2, 3, 4 different ways of doing the same thing. And really, there's no advantage or disadvantage to any of them other than probably this one probably is the least number of keystrokes. But other than that, they're all basically doing the same thing. All right. And I've always said, you hopefully have heard me say this already, and that is that when you're learning to program, you should program for understandability. So in other words, you should set this thing up so that you understand what you're doing. Don't worry about anybody else. Worry about yourself. All right. Now, the next thing, this is relatively new. It says C#11. So it's about as new as it gets. All right. And you can do this. If you start this with 3 double quotes and you end it with 3 double quotes, it'll take whatever you put in here verbatim. In other words, this whole thing that we put over multiple lines is now called raw message. It'll keep the double quotes and single quotes in here, the commas, the dashes, it'll keep everything. There may be a reason you'd want to use that. But again, you need to be running C#11 or above. All right. It is 8:54. Let's go till 9 and then we'll take a break. All right. So how to convert data types. This is new. Yet it's not. What do I mean? Well, you've been using some of this stuff already. Now, when you look at this, it's a little confusing. What do I mean? Well, it says structure, and then it says keyword, and then it says what the value type holds. Again, what the heck does that mean? There is a class called byte from which you create variables of type byte, and they hold an 8-bit unsigned integer. And I could say this kind of thing for each one that's in here. All right. Now, this is where it starts to get a little confusing as well. Okay. Notice you can use string with a capital S, or you can use string with a lowercase s. And it all goes through in here talking about value type and reference type. What does that mean? Well, up here, all right, this is a reference type. This is a value type. Who cares? Well, since this is a value type, this holds the value. Since this is a reference type, it doesn't hold the value in there. It holds the address of where that value lives. All right. That may not make a lot of sense now, but it'll make more sense when we get into talking about this stuff in a little bit more depth and breadth of coverage in a later chapter. All right. Now, some of this that's here, how to use methods to convert data types, some of this we've talked about already. You've used toString. You've used parse. We've started to use try-parse. Now, want to mention a couple things. I'm just going to put up another example here. And again, believe me, I'm doing these off the top of my head. All right. So if I come through here and do something like this, let's say that I say string age str for age string, and I'm going to set it equal to nothing. Then I'm going to say int age, and I'll set that equal to 0. All right. Now I come in here and say write, enter your age. All right. Oops. And then I do age string equal read line. That'll work just fine. Remember, whatever you enter in at your keyboard, the system, it is automatically entered in as a string. All right. The other way that I can do this, we've talked about this before. I'm going to show it to you again. All right. And I'm just going to put that in there. And I'm going to bring this down to here, copy it. All right. Let me make this a little bit smaller. I want you to be able to see everything that's going on up here. All right. So if I come through here and say enter your age, if I don't want to use this age str, I can come in and say age equal either convert dot to decimal, all right, read line. I can say that, all right, or I can say age equal decimal dot parse read line. Now, both of these here are dangerous. And they're dangerous because it assumes that whoever is writing this program is going to actually put in a number. If they leave it blank or they put in something non-numeric, we've looked at this a little bit in the past, the program's going to blow up. All right. Here, it's not going to blow up. But now if we turn around and say age equal, and we can pick again, either one of these, convert to decimal or decimal dot parse, but let's do a convert dot to decimal, and I say age string, I can run into the same problem if I either left this blank or put anything non-numeric into it. All right. That's why we also have this. And I showed you this before, but I want to mention it again. And I want to go through an example in a little bit of depth. And then we're taking our break. All right. So I'm going to put it down here. And I'm going to come in and say, just like we did before. All right. I'll grab these two things. In fact, I'll grab all of this. All righty. So I've got all this. However, I don't want to convert it like this because it may break. It may not work. All right. So what I can do is come in here and create a Boolean, and I call mine result. You can call it anything. But I can say here, result equal decimal dot, not convert to decimal or parse, decimal dot parse. It's a decimal dot try parse. What am I trying to convert? I'm trying to convert age str. And if it works, where am I going to put it? I'm going to output it into age. Now, when I get done with this, result will hold either true or false, because result is a Boolean variable. If it holds true, I put an integer in there. In fact, this shouldn't be decimal. Wow, that should be int 32, not try parse. So anything I put in there, I should have changed all those to int 32. That should be int 32. I'm sorry. Etc. All right. Right. So that is everything. Now, if this returns true, I know that I put an integer in there. If it returns false, I either put nothing in there or a non-numeric value, or I put a decimal place in there. All right. So I can now test for this. This is the kind of thing we did the other day. I can say if not result, which remember is a shortcut for saying if result equal false. They mean the same thing. So I could ask the user to do it again or whatever. What you're starting to learn is what's referred to as input validation. What we've been doing in the past is we've just been assuming that the user does what they're supposed to do, which is a terrible thing to assume. All right? Because a lot of times people are in a hurry, don't read instructions or do whatever. All right? The other thing I can do too is this holds a number. All right, but what if I said age had to be between 1 and 125? All right, then instead of just saying this, I could say something like if not result or age less than 1 or age greater than 125. We could have used constants in there, a minimum age and a maximum age as well. But now I'm testing three things. It has to have given me a number, and that number must be within this range. So like I said, there are multiple ways always of doing the same thing, or taking a simple test and making it a more complex test. All right. So a little more if you want to read on it and hear. Okay. But when we come back from the break, we're going to talk about how to use methods to convert numbers to formatted strings. It is 9:03. Let's take 12 minutes, please, and let's come back rather at 9:15. I've got to get into water, so I'll be right back.
Are you doing live lecture?
I had a break.
Tiffany Harris.
Hmm?
Her sister came in with her husband this morning. That's who I was meeting with.
Oh,
Her husband's looking at doing the drafting program, but her sister said that Tiffany moved to Florida.
Yeah.
She's in charge of marketing for some company down there. Apparently goes really well.
She sent something to, she's on a feed because we were friends. I knew that she had taken something in
Yeah.
Florida.
Yeah.
I guess she got out of the programming part and
But she's director of marketing, but she still dabbles in it because her
Okay.
company has questions all the
okay,
time.
but she's also
Yeah.
was outgoing,
Yeah.
which is different than most people.
Yeah,
in this program.
it doesn't
So,
attract,
yeah.
yeah.
But,
Usually this program attracts.
Right,
like,
but
introvert.
and she's a good person, good student too.
Yeah.
So it's good. It's good to
Doing
hear.
well. Yeah.
Good, thank you.
I guess making good money.
Hey, that's what it's all about, right?
All right, it is 9:15, so I'm going to start back up again. We left off on page 120 here, how to use methods to convert numbers to formatted strings. Now, if you look on the next page here, you're going to notice some of the stuff we've talked about, not all of it, but some of it, and they're going to show you yet another way you can do formatting. Now, when you format, you can use either an upper or lower case. I tend to use lower. I don't know why. It's just something I started doing and continue to do. All right. And the ones that I use 99% of the time are the first three. C for currency, P for percent, and N for number. That's the number, basically decimal places. So if I say N2, it'll be the 2 decimal places. I don't think I've ever used F, D, E, or G in my life. All right. Now, when using the 2 string, you've already seen this. There's nothing new here. What is new is here. There's also a string.format command. Some people like to use this. I don't like it at all. I don't think I've ever used string.format. It doesn't mean that there's anything wrong with it. It just, to me, using this, or now with the string interpolation that we have, I think are much more intuitive and much more straightforward than doing it this way. But again, if for some reason you like that, then use it. All right. It's all in many ways, it's one of those things that if there's 3 ways of doing the same thing, all right, those in this case being either using the .2 string or string interpolation or using string.format, use the one that you're most comfortable with. That's fine. All right. The next thing that's talked about in here is how to work with scope. And what I'm going to do here is I'm going to bring up, this is something we're going to be working towards later. So please don't worry about it. But I just want to show you something here. And that is, if I go to my code here and I go to the top of my program, all right, again, don't worry about it. You'll notice if you look, these constants here, these variables here, and this is something we're not going to get to for a while yet, but these arrays that are in here, they're all declared outside of any routine. They're not inside of any method or function. What that means is they're global to the program. That means that anything you create in the program, anything, can access these variables or these constants. Now, there's nothing wrong with that, except what it can lead to is what are called side effects. Sometimes some side effects are what you want to have happen. Sometimes they're not. What do I mean by that? Well, since we can come in here and since any routine that's in this program, and look how long this program's getting to be, 506 lines. That means that, for example, if age, it's not, but let's say age, all right, maybe it is. If age is a global variable, if it's something that we went and we put in up here, there it is. All right, since we declared it outside of any method or function, that means we could even come in here, say, you know what, I don't like that age. I just calculated, forget it, I don't like this. I'm going to come down here and I'm going to say age equals 21. Now, you shouldn't do something like that. That would be an unwanted side effect. All right. It's again, sometimes side effects are what you want to have happen. Every place in here that's referring to age and age string, these are wanted side effects. You want to do this here. But I could also come in and I could change, let's say this is in this load right here. All right, I could come in here and say age equals 1000 and I don't get any errors. So a side effect means that when you make something global like that, to the program, it means any routine in the program can change the value of the variable, even ones that you shouldn't allow that to happen. All right, I shouldn't let this come in here and change my age. All right, and what you're going to learn, I think it's in chapter 7. I don't remember, it's 6 or 7. We're going to learn how to get around that. All right, how to eliminate side effects, or that the only side effects that happen are ones we want to have happen. So what does this have to do with anything? I've just shown you scope. All right, that when you go and create variables outside of any routine, they have what's called class scope. That means that any part of the current program can utilize them, understands them, can work with their values, can modify their values. All right. So that's what they explain in here. These variables, they live as long as the program lives. If I had come back in here, and let's say in this routine, this calculate H, let's say that I'd come in here and I made a new variable, int hello, and I set it equal to, hello, and I set it equal to 127. Don't ask me why. I just made that up. That means that this variable comes to life right here. And when this curly brace gets hit to end this routine, this variable dies. It's not there anymore. But with all the rest of them, since we define them outside of any routine, all of these, that means as long as the program keeps running, they have a value and they're valid variables. That's their lifetime. All right. The next thing that's in here are enumerations. Some programming languages just call these enums, E-N-U-M-S. It doesn't matter. But what an enumeration is, for lack of better words, is you create your own variable. And it's kind of cool, I guess, when you think about it. So when you look right here, let's go down to the examples that they show here. All right. Now it says enum terms. Then it says net 30 days, net 60 days, net 90 days. Okay. Well, we've created a new type of variable called terms. When we want to use it, we have to use the word, the variable type, so terms, followed by a period, and these are its 3 possible values. Since we didn't give these numeric values here, the system does. It says the first one is 0, the second one is 1, the third one is 2. All right. Now, if we want, we can do something like this. Technically, I don't even know why they put the colon short there. I don't think you need that, but there's nothing wrong with it. Now this is term values, but now it's net 30 days is 30, net 60 days is 60, net 90 days is 90. Most of the time, I'll show you quickly how this is used. All right. This is how I've used it. All right. So you come in here and you do something like this one. So we'll do this. We'll do the enum. I'm going to call it days. We'll put the colon short in there also. Again, I don't use that, but then in here, I'm going to say, it depends. Does the weekday start? I'm going to say the first day of the week is Sunday. So Sunday equals 1. Monday equals 2. Please pretend that I just kept typing. Wednesday is 3, Thursday is 4, Friday is 5, Saturday is, etc. All right, that we kept going. So when we were all done, I'll just put ... there. So if we're done, we would say Saturday equals 7, and then end our curly. Now we can use days.Sunday, days.Monday, days.Tuesday, etc. And in fact, since we made the first one 1, we don't even have to give the next one's values. It'll automatically get 1 more. So Monday will be 1, Tuesday will be 2. I'm sorry, Monday will be 2, Tuesday will be 3, Wednesday will be 4, Thursday will be 5, Friday will be 6, and Saturday will automatically be 7. So you are creating your own data type. Since you're working with your own data type, 2 things. You have to preface it when you use one of these with days, period, and these are the only allowable values that days can have. All right. That's an enumeration. They're kind of neat. As it says, it defines a set of related constants. Each constant is known as a member of the enumeration. By default, it says it uses an int. The first one is 0, the second one is 1, unless you change them. All right, it says to use one of the other integer types, you can put that. So I wouldn't have needed that. I could have just said enum days. Those would have been ints as opposed to a short int. All right. Why they decided to show you that right here and now, I don't know, but they did. All right. The next thing that's in here on the next couple pages may end up being one of the more confusing things that you'll learn about for quite a while in this class. And that is using the question mark right there. This line right here, okay? By putting that in, this line is now legal. What the heck does that mean? If I had said int quantity like that, then on the next line, I put in quantity equal null, I would have gotten an error message because integers cannot, by their very nature, be null. But when we put the question mark there, it says allow a null value for quantity. And if you say, I don't get it, all right, let's look at this one here. Okay, this one says that sales total can be null. So if we don't know what its value is yet, maybe we don't want to set it equal to 0. Maybe we want to set it equal to null. So you can do that. All right. When you work with nulls, these are some of the things that you can work with. I don't want to say any more than that because it's confusing. All right. I'm going to go through the examples at the bottom of the screen here, but for now, I wouldn't worry about them too much because you're probably not going to use them very often. That said, when you take the AWD1100 class, Database-Driven Web Development 2 class, all right, you use the question mark operator quite a bit, all right? And you use that when you're working with databases. We haven't talked about databases yet, so it doesn't really pay to go over that anymore right now. All right, there's also what's called a null coalescing operator. What the heck is that? In English, what this means right here is if quantity does have a value, assign it to QTY. But remember up above, we said int question mark quantity. So quantity can be null. So if quantity is null, assign -1 to quantity. If it's got a value, assign quantity to it. So this is assuming it's got some value. It's not null. If it's not null, assign this to this. If it is null, assign this to this. All right? It's just, for lack of better words, it's kind of a shortcut operator. All right? All right. Then there's nullable reference types. Like I said, this is probably amongst the most complex things that we've looked at so far. All right. So it says that prior to .NET 6, you had to go in and basically make some system settings to allow this to happen, but you don't have to anymore. All right. Now, it talks about that with .NET 6 and later, all right, all project templates allow nullable types by default. That's all you have to know about it. Okay. Now, with that said, it is possible, it is possible that there may be some questions on the written test about the null operator. If you don't get them, you say, I don't really understand. Take a guess. Not going to hurt anything. All right. Okay. So the author comes back here and is going to redo, and I'm going to also, this invoice total form. One of the things they're going to do is they're going to hard code in 25 as the discount percent for everybody. So I'm going to create this right now, and I'm going to even use their names because there's not much code. That's all the code. But I want to go over it with you. All right. So I'm going to build this. I'll try to do it as quickly as I can. So I've already made a chapter 4 and a chapter 5 folder. So I'm going to start up Visual Studio. Create a new project. I will tell you, a couple people emailed me yesterday and said, you know, the test wasn't really much like the pretest. On the pretest, you had a lot of Windows Forms app, and this one didn't have any. Yeah, that's true. Your next test will be all Windows Forms apps rather. So let's make a Windows Forms app. All right, and I'll call this invoice total. All right, I'm going to put it in the folder that's called Chapter 4 as soon as I can find it. That's weird. Let's look here. Chapter 4, it's right there. All right, so let's see if it'll let me do it this way. Desktop, if I put in here, Chapter 4. All right, and I'm going to call the solution name Chapter 4 also. It's going to have two different things in it in just a minute. So this is invoice total in Chapter 4 in solution Chapter 4. Create. There it is. Let's, I'm gonna show you something because what I told you the other day is true, but isn't true. I'm gonna go to this form file right here, and I'm gonna open this one up that I said you should never really play with as Form Designer. And guess what? I'm gonna play with it in a minute. Don't worry about it, okay? But I'm gonna come back here. Oh, I forgot to rename my form. Yeah, I'm purposely forgetting to rename it. All right, so I'm gonna come here. And I'm going to come up and, as always, change the color. All right. So we've got that. And we'll immediately, since it's right here anyway, we'll set the start position to center screen. All right. So we just got that. And what do we have in here? This is supposed to say invoice total for our text. So invoice total. All right. Then I'm supposed to have 4 labels. I'm supposed to have 4 text boxes. All right, I'm going to move that a little closer. There we go. And I'm supposed to have, I'll put 3 buttons in. They have 2, but I'll put a clear button in as well. All right, you've seen me do this countless times. So I'm going to come in here and lasso these and change the size here to 20. Okay, so my interface is basically set up here. All right, I'm going to lock the interface into place. Now, I've got all this stuff here, and I'm going to attempt to change the form name. So I'm going to call this FRM invoice total. FRM invoice total. And I hit enter. And do I want to change it? Yes. And I get that. Now, the only way that what I'm going to show you now will work that I've seen is if I have this designer file open. All right. And in here, it did change it. All right. When I did this the other day, I went back and typed in form 1, just like it was. Then I changed it again. All right. And I typed in FRM invoice total. All right. Just like that. And my errors have gone away. I went back in and saved it. All right. And then I came back into here. Well, it didn't. When I did it yesterday like this, it went back and changed. It accepted it. All right. Here it didn't. So let's try it this way. I'm going to come back and type in form 1 again. Form 1 says, do you want to change it? Yes, I do. All right. Now everything, well, I lost everything, but that's not a problem. But now if I go back into this file and I change this to FRM invoice total like that, just like that, and then come into here and do a rename and put in FRM invoice total and hit enter. Whoops, and I don't want to do that. I got a capital T there. All right, and hit enter. All right, then it took it. Doesn't look like it likes it now. That's not a big thing one way or the other. I'm just going to go back and reset it to form 1. All right. I love that when I try to show you something and it doesn't work. All right. So we go back. Sorry about this, but let me, I don't think it'll Control Z will bring it back. No, it will not. All right. All right, so there's my interface. Again, it's okay. I'll lock it into place. Let's set up what we always set up here. So BTN calculate with calculate in there, ampersand calculate. Then the next one, which is clear. So C ampersand LEAR. And our last one, which will be exit. All right, now we've got 4 things in here. I'm purposely leaving this blank. All right, so this is subtotal, and they called it in the book TXT subtotal, which is fine. I'm sorry, LBL subtotal. And it's got the word subtotal in it. All right, this next one, so we'll make this TXT subtotal. All right, the next one is discount percent. And I'm going to make, again, I'm using their names. So LBL discount PCT. Right. And this label will be, sorry, this text box will be TXT discount PCT. And I didn't put the wordage in there, so that's got to say discount percent. All right, I'll have to widen that out a bit. That's okay. We'll do that in a second. Then we've got discount amount. Again, when we widen that out, that'll be fixed in a second. LBL discount AMT, and this will be TXT discount AMT. And finally, we'll have just TXT total and LBL total. All right. These three are going to be read-only. All right, let's change these. Right, I'm going to move these over just a little bit. Fine. There we go. All right, you've seen all this kind of stuff before. We're going to do that in a minute. I still have that, I believe, saved over here someplace. There it is. All right, so all of that should be working now. I didn't set my clear button and accept buttons. We'll work about that in a minute. If I put this in and come down to here, should clear, and it is, and exit is working as well. Okay, good. Let's quickly set those. So our accept button will be calculate, our clear button, our cancel button, I should say, will be clear. I thought I'd set the start position, but I guess I hadn't. All right, or it got reset. So there, all that's done. And let's do the tab order as well. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Another view tab order, and let's do the calculate. I'm going to call this just calculate total, and I'll put it down here. All right, there's not much code in here, as I mentioned. All right, so I'm just going to put it in right here. Calculate total. There we go. All right, there's about 10 lines or so, so let's put it in. One more line. All right, that should be everything. Let's run it using the data they show in the book to make sure that it works and it works correctly. So they put in here $225. And of course it breaks. So let's see. Input string was not in the correct format. So total. Convert to decimal. TXT. That should be subtotal there. That's why it's breaking. I'm using TXT total and it hasn't been set yet. So that's subtotal. I think there's no. There we go. Try it again. File, save all. All right, 225. And I get the same exact stuff that's in the book. So you're like, that's fine. Who cares? Well, a couple things. First of all, piss poor written program. What do I mean? Well, if that's going to always be that, the first thing they should have done is get rid of that, come up here, and up here at the top, they should have put a const decimal. All right. And then DISCOUNTPCT like that. That should have been done. All right. I mean, is this a big thing? No, but we want the program to be as well written as possible. All right. Second, this is assuming they put something numeric in there. You've already seen. So if I come through here and I've got nothing in here and I click calculate, the program blows up. All right. This would have been a much better example had they gone in here and done this and just said bool result. All right. And then said something like result equal. All right. In fact, we could have even said here decimal subtotal, but not given it an amount. All right. Then come in here and said this. So we would have done a decimal dot try parse. All right. Like this. So decimal dot try parse txt subtotal dot text. And what doesn't it like? It says, oh, because I haven't told it where to put it. And then out subtotal. Like that. All right. Still doesn't like something. We're going to fix it right now. So what doesn't it like? The name subtotal. Oh, because I spelled it wrong. Here we go. All right. Now, let's make that the same way it is later on in the program. So there we go. Whoops. There. All right. Now we can come in and say something like if not result, and all I have to do is return. Now, if I put nothing in there, or I put something non-numeric, it's not going to blow up. So I can go in here, leave it blank, and nothing happens. All right, I should go back and reset the focus, but I can put this in and nothing happens. So what I should do is if that happens, I should say txt subtotal dot text is equal to nothing and txt subtotal dot focus. All right. Now, the only other thing I wanted to mention in here, if we wanted it to allow it to be null, we could have come in here and done that. We could have done that. All right. I didn't want that. All right. But there are going to be times maybe when you do want to. Okay. So now with making just a few fairly superficial changes, now nothing happens. And if I put this in there, it clears it out and nothing happens. The only other thing I might want to check is when we've got this if not result, well, we really shouldn't allow a negative number in for subtotal. That doesn't make any sense. So we could say, for example, or subtotal less than or equal to 0. All right. So now if I come through here and I put in a negative number, it again isn't going to take it. All right. Why am I telling you all this? First of all, we're trying to take a fairly poorly written program and improve upon it. Secondly, what you should notice in here is, again, I'm not putting any code in my click events other than a call to a routine. There and there and there. Why? Who cares? That's what one of the later chapters is going to be all about. And I think we'll be able to go through that chapter fairly quickly, just because so much of it is going to be redundant from stuff we've already done. All right. Now, I'm going to show you something we haven't talked about yet. All right. And it's not going to take long to show you, but I want to show you something. All right. And that is this. I'm going to change the name of my folder here to C# chapter 4, because I may have one already out there on GitHub called chapter 4. I don't know. So I'm going to make that C# chapter, yeah, because it's already running. So let me stop the run here. Now I'm going to just change this to C# chapter 4. And I'm going to change this one to C# chapter 5. All right, I'm going to bring this one back up again. All right, now I'm going to go into GitHub. And I'm going to just get into my GitHub account. All right, and I'm going to make a new repository that I am going to call C# chapter 4. Should say it's available. It is. I'm going to make it public. And I'm going to click create repository. And now I'm going to grab that second last line here. Copy it to the clipboard. All right. Now, excuse me, I'm going to go back into here. I'm going to right mouse click and choose my Git bash here. There it is. Let's bring it down. Make it bigger. So I'm going to say Git init, which makes my Git folder up there. There it is. Git add dot. Okay. That adds everything to it. Git commit -m chapter or programs. All right. Now it doesn't like something. Oh, git commit -m. It says untracked files. Chapter 4 solution and invoice total. Nothing to add. Not sure what that problem is. Maybe it's because I changed the name. I don't know. But I'm going to put this in, which has got my path. All right. That looks good. Git commit -m. Well, it's still giving me, I don't know if it put it in there or not. There's a reason I'm doing all this. Let me try to see if I can do a git push -u origin master. All right, it says error, failed to push some refs, which means somewhere in here, and I'm going to look, I screwed up something. Let's look. Git init, git add dot, git commit -m chapter 4 programs. Trying to think of what's wrong in there, but can't think of anything. Git remote, clear. All right, I'm going to go back and try to rechange the name of this. So change the name of this. C# chapter 4. I thought that was the same name I used here. C# chapter 4, chapter 4. All right. All right. It's going to make me go back and do this. There's actually a reason I'm showing you this, and it's not to waste my time or yours. All right. First of all, I don't want this one anymore. So I'm going to show you how I can get rid of it, or at least see if I can. I'm going to go to settings, and I'm going to go way down to the bottom. And this is how I can take something that was public and make it private, or something that was private and make it public by changing the visibility. So if I wanted this to become private and I made it public, I could click here and change it to private or vice versa. But I want to delete the repository. All right. And yes, I want to delete it. It says, hey, are you sure? Did you read everything? Yes, I did. And then it says to confirm, it still makes you type all this. So JP Scott Rankin /C# chapter 4. Now it's gone. Well, it's not gone yet. Now it's gone. All right. So I'm going to add a new one. I guess it wanted chapter 4 there. So hopefully I don't have one called chapter 4. I don't. Good. Again, it'll be public there. All right. Now I'm going to get an error. I want to show you this. I've already set up in here, or I tried to set up. All right, I'm just going to get rid of Git. That'll get rid of any errors I've got. And I'm going to bring it back. So hopefully I get no errors now. Git init. Git add dot. Uh-oh, it says adding files failed. Son of a gun. All right, let me just tell you what I'm trying to show you. All right, and that is if I go into here, okay, one thing that you are able to do is after you create a repository, you are able to go back in and update that repository. Who cares? Well, what I'm going to do is I'm going to go back and I'm going to take the same file we've been working on and I'm going to make it into an enhanced version of this program. All right. And let's say, so I come in and I'm going to do this right now. All right. So I'm going to come in here, and if you remember how this looked, we're going to add 3 right here. We're going to add 3 more labels and 3 more text boxes. All right, so I'm just going to grab these and copy them and paste them, and then put them right here. All right, and we're going to rename all this stuff in just a second. But what I wanted to show you is, after we do all this, let's say we make all these changes. All right, and guess what? Nothing works. Everything's broken. And you say to yourself, man, I wish I could just go back and have the one that I created that just had this stuff. You can go and do that in Git. You can bring up an older version and start working with that one. All right. If you remember, when we looked at this, when we did that Git remote -v, it said on there both fetch and push. All right. When you push, you're sending stuff out to GitHub. When you fetch, you're grabbing stuff from GitHub. You can grab an older version of your program if you'd like to do that. And that may not sound important. It is. All right. It's bailed me out of a few times when I've screwed things up. So this is going to be LBL number of invoices. All right, now in the book, they spell all that out, but I might not have enough room. So I'm just going to make a number sign. All right, so I'm going to say number of invoices, like that. And this will be TXT number of invoices. All right, this next one is total of invoices. Hoping I'm using the same names that they use in the book. And the last one will be average of invoices. Which will make this TXT AVG of invoices. Let me double check here and make sure I've renamed everything. I did not. Notice text box 2 is not renamed. All right, I don't know, is it that one? Nope. Nope. Yep, nope. Something is text box 2. Must be this one. All right, let's let the system find it for us. So wasn't there a text box 2 in here? Maybe not. So the form is not. Everything else looks like it is renamed. All right. Technically, right now, all of you should be able to figure out exactly how to put in these 3 boxes. Now, I'm going to show you, and I'm not going to use the book, but I'm going to show you, and it should make sense because in future programs, including homework, including tests, you're going to have these in here. These again are accumulators. You're accumulating the total number of invoices. You're accumulating the total of your invoices. You're accumulating the average of your invoices. Okay, so I'm going to come in here and go down to calculate. Now where we have these, that's all of our calculations. All right, now I'm going to put in here update totals, which doesn't exist, so I'm getting an error. So let's put that in. Private void update totals. All right, we've got 3 text boxes. The first one is our total number of invoices, which we called right here, TXT number of invoices. All right, so the first thing that we can do in there is to add 1 to the total number of invoices, plus total number, that's what, TXT total number of invoices. All right, in fact, let's not do that. Int total number of invoices. All right, we'll set that equal to 0 and let's make that global. So I'm going to go up here. This is where we did what? We did a declare and initialize program constant. Now we can go in and declare and initialize global variables. We're going to have 3. An int for our total number of invoices, a decimal for our, we'll just call it invoice total. All right. And a decimal for invoice average. All right. So now I can come in here and what can I do? Update totals. Well, first, I want to increment my number of invoices. So plus total number of invoices it is. Okay, so that's first thing. All right, next, I want to add the invoice total to the, what do we call it? To this, to invoice total. All right, so we want to come in and add the current invoice total to the invoice total accumulator. So invoice total plus equal, and what did we call that up here? Well, we're gonna run into a problem, and I'm going to show you what that problem is. All right, right here, we've got invoice total, and right here, we've got invoice total. That's going to be a bad thing. So let's change this one. We'll call this invoice total of all invoices. And we'll call this invoice average of all invoices. All right. We're still going to have a problem, but we fixed part of it. All right. What is this? Well, we want to add to this what? Our invoice total. And guess what? Okay. It's like, no, I don't want that. I want this with an I. And I'm getting an error. It's not working. But what's the problem? The problem is I defined invoice total in here, and I defined it as a local variable because it's inside of here. Because it's inside of a function. How do I fix it? Well, all I'm going to do is grab this, cut it, and now I'm going to type in here invoice total. It's going to be an error for just a second, but as soon as I come back up here and I say decimal, all right, invoice total, I guess I already had it, equals 0M, now everything will be fat and happy. So now I can come in here and I can say invoice total of all invoices and add to it the current one. Then I can add, I should say, divide the invoice total of all invoices that by this. To get the invoice average of all invoices. So invoice average equals invoice total of all invoices divided by total number of invoices. Finally, all I have to do is fill in the 3 text boxes. So TXT, we call it number of invoices. Yes, we did. Dot text equals total number of invoices dot to string. There's no formatting on that because that's a whole number. TXT what do we call that? So that's TXT total of invoices, and that's TXT average of invoices. Okay. So TXT total of invoices dot text equal dot to string currency. And then finally, the last one, that's average. Right, and that's it. So file, save all. I'll put in 2 of them because that'll be enough. So 500. All right, we've got 1, it's 375. All right, let's put in 1,000. So 375 plus 750 is 1125 divided by 2 is 562.50. Ideally, what you see is it was very easy to take this program, add a few things to it, all right, and pretty it up, whatever you want to say, to make it work a little bit nicer than it did before. The reason I wanted to show you this, though, is in the textbook when they did it, all right, they started to do a little bit of modularization. So again, rather than putting something in a click event, all right, they're starting to do more of, so rather, to actually not put code in the click event of something. All right. And like I said, I want to make sure when we get to that point that you're like, oh, okay, yeah, we went through this already. But we can review it. But we shouldn't have to spend a lot of time going over it. All right. So this was everything that was in there. We're almost done with this chapter, ready for another break. This was the enhanced one. I didn't use the same name as they used. Notice they used math.round. All right. I just would, on mine, when you format it to currency, it's supposed to put it to 2 decimal places already. So theirs is going to look similar to mine, but not identical to mine. All right. Whose is better? Just draw your own conclusion. All right. So we're going to take another break. It is just about 10:15. We're going to take until 10:25. And when we come back, we're going to go over chapter 5. So I will see you in 10 minutes. Again, gotta get another water. All right, it's 10:25, so let's start on chapter 5, which is on control structures. Much of the information in here you've already had, some is new. All right, when I say much you've already had, you should already understand Boolean expressions. A Boolean expression is an expression that must evaluate to either true or false. All right, we've talked about relational operators already. Greater than or equal to, less than or equal to, and equal to and not equal to. We've talked a little bit about logical operators already, not, and or. All right, we've talked about how to code an if-else statement. We have not talked about switch statements or switch expressions. All right, I don't know if we've used the conditional operator yet or not, but we're going to look at that. Last week, or I shouldn't even say last week, the other day, I showed you quickly loops. I showed you the while loop. I showed you the do while loop, and I showed you the for loop. All right, so we'll review those, and then we'll look at the future value app that puts all these things in together. This is a shorter chapter than the last one. Again, I'll go till about 11:15 or so, and then we'll see where we are. All right, if we get through the whole chapter, that's fine. Then we'll be done by 11:15 today. All right, otherwise we'll take a 10-minute break and then finish it up. My plan is on Monday of next week, all right, I'm going to go over at least 4 different programs with you, and I'll show you them quickly just so you can see them. And that is, we will go through, we've already done this one, the calculate area and perimeter, but we will go through this accumulate test score data, extra 4-2. We will go through extra 5-1, calculate the factorial of a number. We will go through extra 5-2, calculate change. We will go through extra 5-3, calculate income tax. After we get done with that, we'll see where we are. All right. But I'm going to, again, try to come in and prepare for you at least 3 to 6 extra programs and go over those with you as well. And then if we, whatever we don't finish, we'll finish that on Tuesday. Then Wednesday, I will give you another pretest. Now, when we did the last pretest, we pretty much just did it together. I'm going to give that to you, and then I'm going to give you some time to work on it, and then I'll do it the next day. But I really and truly want you to try it. I'm going to base this pretest that I'm going to create for you off of the exact test that you would take probably next Thursday. All right, just so you have an idea what's going on next week. Then on Friday, we'll go over 6 and 7. All right, so that's the plan right now. Now, I'm going to slow it down. I am purposely speeding it up. All right, and if you look on the syllabus, it said in there that a lot of the Friday days were going to be days where you could work on stuff. Well, I didn't want to make this one because I've already done for you the homework that's due this weekend. That's on one of the lectures I gave you. I didn't save it as a GitHub repository, but I went through them. And we went through one of the 3 chapters for the written test that you have to do. So a lot of the stuff that's in here, all right, for Sunday, that's due Sunday, we've already done. All right. So let's get into this chapter now. So again, here's your relational operators. All right. They're the same 6 that I mentioned to you previously. I'm going to guess that, you understand the greater than or equal to, less than or equal to, because you had that math while before high school. When you are testing for equality, again, you must use a double equal sign, not a single. In fact, the way it works today is a single equal sign, I believe, will give you an error. The inequality is an exclamation point followed by an equal sign. Sometimes that exclamation point, people say it looks like a bat, like a baseball bat. So you'll either hear it called bat equals, or sometimes it's even called bang equals. Now, with some other programming languages, when you're doing inequality, another way you can do it is to have a less than sign followed immediately by a greater than sign. So you can do inequality like this. This isn't one of those languages. So if you're checking for inequality, you have to do it this way. All right. And again, they give you a lot of examples here. But these are used to create Boolean expressions. If first name equal Frank, if txt_years.text equal the empty string, if message equal null, etc. All right, and the logical operators. Now, I may have mentioned this before, but I'm going to say it again anyway. All right, the major ones that you're going to work with most of the time, all right, are going to be, well, actually, you'll work with all of them. But notice it says conditional and conditional or, all right? And you may have seen this already, especially if you've gone back and watched any of the tapes that I did earlier that were on the PowerPoint slides. So if I come through here and do this, if I'm making all this up, so int x equal 12, int y equal 15. All right. Now, if I want to say this, if x is greater than or equal to 10 and y is greater than or equal to 10, then do something. I don't care what. I'll just put ... here. It means do something. All right. Now, this is true. And this is true. Since, the and is expecting something on the left side and something on the right side. Okay. Since they're both true, it's going to do this. What if we had done this? All right. Well, what happens is C# uses something called short circuit evaluation. And what that means is it checks this. And since that's false, it never checks this one because it doesn't have to. Because with an and, both sides have to be true. Since it's already found out that this side is false, it doesn't check this one because it doesn't have to. If you wanted to check it anyway, you can just use one of these. That's not done often. All right, usually there's not a reason for doing that. Now, on the other hand, when we did this before, if you use or, which is two pipe signs, it does again short circuit evaluation. With an or, just either one of these have to be true or both. But since this is true, all right, 12 is greater than or equal to 10, it doesn't check this side. All right. So when you are working with short circuit evaluation, if it's an and the first condition is false, you don't check the second one. If it's an or and the first condition is true, you don't check the second one. All right. So that is anding and oring from right here. All right. Again, then you've got, like I said, you can put this in there. And that always, even if this is 20, it still checks both sides. All right. And if I put this in like this, all right, it still checks both sides. Even though with the first one, it already knows it should do it anyway. Now, the natural question then would be, okay, then why would you ever do this? Maybe you're actually keeping track. I don't know. I mean, like I said, I don't know. Maybe you're just keeping track and you want to see how many times you check this, it's true, and how many times you check this, it's true. So you want to check both. So you can do that. All right. The last one that's in here is the not. That is also known as an inverter. What does that mean? It makes true false, or it makes false true. All right. Not married means you're single. Not single means you're married type of an idea. All right, so it changes stuff. You saw this before where we did something like this. We said if not result. And I said that was the same thing as if you said if result equal false. All right. Now, what if you have a very complex expression? What if you have a very complex expression? All right, what are you talking about? Well, if you've got something in here, in fact, I'm not going to use, I'll just use one set of parens. Not a great example, but it'll work. All right. If you've got a very complex expression that contains ands and ors and nots, all right. If you've got a complex expression like that, unless you use parentheses to override, you always do the not first, always. All right. Then you do the and, then you do the or. That's the order in which these are done. So this is going to be done first. All right. Then this is going to be done. Then this is going to be done. And finally, this is going to be done. Now, if you say, well, that's really confusing, then you use parentheses wherever you need them. So if I put parens here and here, it's going to do that first now. All right. That's the innermost set of parentheses. Then it's going to do this because that's the next innermost set of parentheses. All right. Then it's going to do this. And then finally, it's going to go in and do this. All right. So when you are building a really complex expression like this, and that pretty much is, you want to build it in stages and make sure, first of all, hey, check this out. Is this doing what it's supposed to do? Oh, yeah, it is. Then maybe check this out. Is that doing what it's supposed to do, etc. You don't want to just throw something really complex together. All right, you want to build it in stages. All right. Now, we've talked about the if. When you look in the book here, all right, just so you know how to read this, if Boolean expression, curly braces, then one or more statements. Else if, notice there's a bracket here and a bracket here and a bracket here and a bracket here. That means those are all optional. That means you don't have, if you've got an if, you don't have to have an else if, you don't have to have an else. And that's what the example below shows. Also notice that after the else if, there's 3 dots, which means you can have as many else ifs as you want to or need to have. All right, just so you know how to read this. So here's an if with no else and no else if. So if your subtotal is less than 100, you're doing nothing. Again, I would have put curly braces in there. They didn't. Since this is a block, since there's 2 statements you're doing here, you must use the curly braces or you're going to get either an error or not the results that you want. All right. Here's an if with an else. And again, I wish they would have used curly braces. But when you get done, when you get down to whatever code is down here, Either the discount percent will be 20 or it'll be 10. It has to be one or the other. Either this statement has to be executed or this statement has to be executed. Only one can be executed, but one of those two must be executed. All right. So here is an if with a series of if else's. If you've got an if with a series of if else conditions, like is shown right there, it is not mandatory to have a final else. Many programmers will put in a final else as for like a fall through type of statement. So if none of this is true up here, then do this. All right. You can also put an if within an if. The key thing to realize about this code where it says nested ifs, now right here at the top of your screen, you don't get into this inner if statement unless the customer type is R. All right, so if it's not, you skip it and you go right to here. If it is an R, then you check and you say, okay, if this is true and this is true, then the discount percent is 20%. If this is true, but this is false, then the discount percent is 10%. All right, let's do this right now. I've done this kind of thing before, and it may help and it may not, but I'm going to anyway. All right, so I'm going to write some code here. And I'm just going to write it like in here. All right. And I'm going to expect you go to a store, okay? And I'm going to expect right now that this store has 3 sizes, a small, a medium, and a large. That's it. I'm an extra large myself, so I couldn't buy from this store, but I want to show you this anyway. So I'm going to put in here, right, enter, size. And I'll even put in here, small, medium, or large. All right. Just so the person knows exactly what it is they're supposed to be putting in there. All right. And then I'm going to say string size equal read line. All right. You've seen stuff like this before. So that should say this on the screen. Enter size, small, medium, or large. There should be a tab. And then the cursor should stop and wait for you to enter something. All right. So we'll come in here and we'll say if size equal. In fact, I think we can do a read line, and I'm going to do a .to upper. That's going to put it into uppercase. So I'm going to say here, if size is equal to a small, okay, then I'm just going to do a right line. Your size is small. Again, that should be pretty obvious. All right. Now I'm going to make this a little smaller so it doesn't scroll off the screen. All right. Else, if size equal M, deal these. Your size is medium. Grab the whole thing here. Else, if it's an L, the size is a large. Now, if you were 150% sure that nobody else would put in anything other than what's shown here, you can be sure that 100% of the time, 100%, that what's going to get put in there is going to be an S, an M, or an L. Then you don't really need this. You could just say else. But I'm going to just come in here and say else, right line, unknown, size, because that's what it is. We said the only thing that you have there is a small, a medium, and a large. Now, you should be at that point in your programmatic career here that there should be nothing in there that doesn't make sense. All right. I literally mean that. Everything that we wrote here should make sense. All right, now I'm going to do one more thing. I'm going to make this one more time a little bit smaller. Try making it like 28. That should work. Why? Because this, I want to redo this. And I'm going to do it right next to where it is. But now, rather than doing this through if statements, I'm going to use a switch. So I'm going to do a switch on the size. Switch statements must be within curly braces. All right. And I'm going to say case S. And I'm going to steal this. Whoops, I don't want to do that. Your size is small. Make it a little bit smaller. All right. And then, not there. Then I need to put in the word break. And we're going to talk more about break in just a bit. Case, medium, your size is medium. Case, L, your size is large. And finally, all right. I can't think of a better way of showing it to you than showing it to you like this. Don't get me wrong. I'm not saying, boy, did I write this fantastically. No, I don't mean that at all. But there's, should be, you can see both of these now. So you can see an if versus using a switch. Now, switch has evolved over the past several years. You can do things with a switch now that you could not do previously. If you remember, it used to be. Okay, I'm going to just explain to you quickly how it used to be. And that is the way that it was previously. If you remember that program we did on grades, we said something like, if number grade is greater than or equal to 90, letter grade is A. Else if the number grade is greater than or equal to 80, the letter grade is B, etc. It used to be that when you did this with a switch, you had to list every possibility. So you'd have to say case 90, colon, then underneath that case 80, I'm sorry, case 100, colon, case 99, colon, case 98, colon, case 97, colon, all the way down to 90. and then say grade is an A, then do all of them. So people didn't use cases nearly as much as they do now. All right. But when you take a look at what is in your textbook, they're going to show you again how the switch statement has evolved over time. Now, break means just that. Get me the heck out of here. So in this example, they show right here, a little different than mine, but in this example, let's assume for a second that the customer type is R. We're going to assume two things. Number one, the customer type is R. Number two, we've removed all of the break statements. Then what's going to happen is it's going to do everything because break means get out. So it'll set discount to 30 or discount percent to 10 rather. All right. But since there's no break, it'll also set it to 20. And since there's no break, it'll also set it to 0. Since 0 is the last one there, it'll be 0 regardless. And if it was a C, it'll of course skip this, but then it'll do this to set it to 2, then it'll reset it to 0. All right. Here's an example where you've got two cases, R and C. And in both cases, the discount percent should be 20. Then you've got a T. I don't know what these stand for. It doesn't really matter. All right. And there, the discount percent is 40. So yeah, there's a lot of stuff in here. Name, case, label, all this other stuff. But the key thing to realize is you switch on something. What you switch on, it used to be not many years ago that whatever you switched on in here had to be a number or a variable that represented a number. Now you can switch on a string. You used to not be able to do that. You can do that now. That's what they're doing here. So you've got switch followed by in the parentheses, what you're switching on, then in curly braces, one or more cases. All right. And if you want to get out after doing something, you must add the word break in there. Okay. Now, to show you how this has evolved over the years, as I mentioned, there are now things called switch expressions. Now, please look at this. This is very, very important. The way that we have been creating our programs in here, if you remember, all right, when we create the programs, we've been coming in, just to show you, we have been coming in and doing this. We have been, going to our solution. Let's say I wanted to add a new one here. Click Add New Project. And we've been using Windows Forms app or .NET Framework or Console.NET Framework. If you use either one of these, you cannot use any of these new fangled things with a switch because it requires version 8 or above. And the version of the framework we're running is either 4.8.2 or 4.7.2. I don't remember. So if you want to be able to use this new stuff that's 8, okay, 8 or above, then when you come in here to create this, then rather, oops, not like that, sorry. Then rather than choosing Windows Forms app.net or console app.net, you'll be choosing the console app, the one that's not .net. All right. I want to show you this. It's actually kind of important that you realize this. So why does this matter? I'm going to bring this up right now. I'm going to use this one right here, and I'm going to click next. All right. And I'm just going to put test. All right. And I'm going to click next. Now, this we haven't been seeing before. This says .NET 8.0. All right, so I'm going to click create. It doesn't look exactly the same as the other one did. We get this. So we've got to do some stuff on our own here. Right? That doesn't matter, but what I want to show you is this. All right, and that is this invoice total that we did before. The one we were just working on before the break, this one. If I go in and click on project and I go down to the very bottom and I choose properties. All right, it's telling us that we're running .NET Framework 4.7.2. So anything that has been added to the software since then, we're probably not going to be able to use. On the other hand, if I go back to what we just put in here, and I go to project and I go to test properties, it's going to look different. Now notice we get .NET 8.0 in 3 different places here. I think it's 3.1. No, just that one. All right. But we can target in here, OS. We can do the startup. There's a couple things in here that we can reset if we want to 8.0. This is the big one. The target framework previously was 4.7.2. Now it's 8. All right. So if you want to be able to use some of the newfangled stuff, you're going to have to not use the .NET framework as we've been using. So as we move on in here, there will be times I will be using the .NET Framework 1, and there will be times I will not be using it. And I wanted to mention that to you, just so you understand, kind of for lack of better words, all right, the difference between the two. Okay? All right. So what are these differences? Well, notice now with this, and now notice in here, it says 8 and later. So I should be able to use that one in there. Now you can use what's called a switch expression. This looks really weird. All right. So what I'm going to do very quickly, just so you see it, all right, is first I'm going to copy this because I always screw up the syntax. Okay, so let me just grab that, copy it, and let me put it, we'll put it in here. All right, no, that didn't do it. Copy. There we go. All right. I'm going to come in here and do this. Just give me a second here. I'm going to type in size, switch. All right. So what am I doing here? Well, you've already seen the if. You've seen a regular switch statement. Okay. I don't think anybody disagreed with that. All right. Now, I'm going to come down here and on the bottom, hit enter a bunch of times. All right. I'm going to come over to here. Paste this in. I don't want this. All right, just like before, we're telling you to enter one of these, just like we did before. All right. But now, grab that. All right, size switch. Well, I'm going to have to change this because it's wrong. All right. Just like before, small, medium, large. Okay. And I'm going to grab this. Right line, your size is small. And that's got to be a comma because of the way they've written this. All right. Medium. Your size is medium. All right. Large. Your size is large, so that one's okay. This has even got a name. This is called discard. It's a discard value. Why that name? I don't know. Somebody named it. And this one will say unknown size. Now, it may not seem like a big thing to any of you, but look at the difference in the number of lines of code you put in between this and this. All right. And there's other ways too that you can write some of this stuff. But what I wanted you to realize is one of the reasons I believe that this was added to the language was the brevity that it produces. Now, this is a default case. You don't need to put that in. All right. But if you do, it's expected you're using that underscore. Again, it's called a discard value. It also expects there'll be a comma after the end of each one of these cases. And you'll notice the word break is gone now. It's not in here anymore. You can still use the standard switch. Sometimes that's the best way to do something. Or in some cases, this is a much better way of doing something. What I'll try to remember to do, the other day when I went over those looping examples, I sent you loops.txt. I'm going to save this and I'm going to save it to this desktop as selection.txt. And I'll send you this. All right, so you've got a copy of it if you ever want to take a look at it. All right. So as it says, a switch expression begins by evaluating its match expression. All right. That is this. They're all the same. Okay. After evaluating, it goes inside and it tries to find a match. If it does not find a match and you provided a discard value, it does that. If you have not provided a discard value, it does nothing. All right. Okay. There's even more. You can use pattern matching in here. What does that mean? Well, look at the pattern. This first example says, if your purchase is less than $100, your discount is 0. Otherwise, if your I should say subtotal is less than 100, then the discount amount is 0. If your subtotal then is between $100 and $200, all right, then you get 20%. If it's between $200 and 1 cent and $500, you get 30%. Otherwise, it's more than 500, so you get 40%. There it's working, like I said, with patterns. What's really nice about this, and I'd write it, except I'd screw it up. If you remember when we did that grade program, all right, and we did the one where you used the when we used the rank and grade pattern in there, we could rewrite that was used all with ifs. We could rewrite it using a switch expression with logical patterns, something like this. So here, this is even better because notice greater than 100 and less than. So this is a logical pattern. So it uses the word and. It doesn't use a double ampersand. Another thing that's new here. All right. So there are uses for this. Okay. And what this can do is this can easily mean that you would have less code. All right. All right. So I'm going to write a little bit more code down. I'll do it in this example, but we'll put it down here. Okay. So I'm going to do this. I'm going to say int a equals 7. Int B equals 23. Again, nothing special about these names. Int max. All right, you already know this, that I can do something like this. I can say, as an example, okay, I can come over here and I can say, if, it should have been an A, but that's fine. If A is greater than or equal to B, all right, if A is greater than or equal to B, all right, max equal A, okay? The biggest one is A. Oops. Okay, so I've got that. Else, put your fingers on the right keys. Else max equal B. Now that should be simple enough that I would guess everybody in here gets that. But believe it or not, I can replace all of this, and it's not a lot. Right here, 1, 2, 3, 4, 5, 6, 7. I can replace all 8 of these lines with one line. That is, I can do this. I can say max equal A greater than or equal to B, question mark A, colon B. So again, what I'm telling you is this line of code, which we'll go over in a second, this line of code, it's called the ternary operator because it has 3 things, 1, 2, 3. All right, it's also called the question mark colon operator. This says, run this test. Is A greater than B? Well, you can see in this case, it's not. But if it is, then take A at whatever comes after the question mark. So take A and assign it to max. If A is not greater than or equal to B, which it's not, then take B and assign it to max. All right. Now, it's interesting. I went to a conference years ago and people were talking about this operator. And they were saying, how many people in here actually use this? And I was surprised. I use it, not a lot, but I use it. All right. And there were probably 50 teachers in the room. And there was only 2 or 3 that raised their hands. All right. And most people said, no, I'd rather do it like this, which surprised me. I thought, well, why would people want to write that if they can write this? I can see if you're just starting out, this might be much more straightforward. But overall, I mean, if you can tell me you got your choice, you can write 1 line of code or you can write 8. I'm going to take 1. All right. So that's what they mentioned in here about this conditional operator. Again, also called the ternary operator, also called the question colon operator. All right. So they show their own example here where discount percent, take the subtotal. If it's greater than or equal to 100, you get a 10% discount. Otherwise, you get a 5% discount. Then they rewrite the whole thing again, and they have rewritten it, as you can see, as an if with an else. All right, so next they've got an enhanced version of the invoice total app here. All right. I don't even know if we need to go over this, but let's just take a look at what's in here. All right, now there's a customer type, as you can see at the top. So we've added another field in here. All right, we've added another field. So it's both another label and another text box. So there's 2 inputs in here now. This is no longer 25. It's not 10 either. It's predicated on the type of customer you are. If you're an R customer, you get no discount, probably regular. If you're a C customer, you get either 20 or 30%. If you're not an R or a C, you get 40%. This stuff is pretty much all the same that we saw before. All right, it's all what is done inside of the if statement here. And again, what they've done here
with the if, especially this outer if, where you've got if customer type equal R, else if customer type equal C, else, that could have been totally rewritten, and it could have been totally rewritten using a switch statement. The stuff that's in here could have, and in here, they both could have been rewritten as switch statements that use either regular expressions or that use patterns that we just looked at. All right. You get to the point where, geez, there's so much stuff in here. Well, which one should I use? It goes back to what I mentioned to you before. It's the one that you find the easiest for you to understand. All right. The one you find the easiest for you to understand. Okay. And the one that makes the most sense to you. And those two go hand in hand. All right. I gave you this the other day, so I'm going to bring this back up again. So I don't know where I put it, but we'll find it. There it is. All right, we looked at this the other day, and I said if your goal is to print out the numbers from 1 to 10, I showed you 3 different ways of doing it. Those were by using a while loop, a do while loop, and a for loop. And a while loop and a for loop, the first and third ones, they're both called pretest loops. You test the value of LCV, which is your loop control variable. You test the value of the loop control variable before you go into the loop. If the test fails, you never go into the loop body. And the loop body is everything between the curly braces. All right. If it's true, you go through it. When you go through the loop body, you must change the value of the loop control variable. If you do not change the value of the loop control variable, you are putting yourself into what is referred to as an infinite loop. Now, there is code that actually runs as an infinite loop. All right. You might have an application that you want to be up and running 24/7. So you can set it up as an infinite loop. Most of the time, when you get into an infinite loop condition, you've made a mistake. All right. And it used to be a lot worse than it is now. Just tell you very quickly, I don't want to bore you with my war stories, but I'll make it short and sweet. That is, when I was your age taking this, we were hooked up to what was called a mainframe computer. So our machines were known as dumb terminals. We were all sucking off of a big computer. And if one person got their program into an infinite loop, it would bring down everybody because we were all connected. It would keep running it and running it and running it and running it and running it. And eventually we would all go down. All right. So we're initializing our loop control variable there, or there, or there. We're testing our loop control variable here. Since it's a pretest, we test it before the curly braces. Here, since this is a post test, we're testing it after the curly braces. Or here, again, since it's another pretest, we are testing it before the curly braces. Finally, we're changing the value of our loop control variable, either inside of the loop like we have here, or inside of our for loop condition that we have here. And now you know that rather than putting this in, it's much better to just put in plus plus LCV. All right, we talked about that now today. Same thing here. And we can do it here too. All right, so those are shortcuts that you can take. But when you take a look at what's in your textbook, I actually have gone over everything, I think at least, that's in here. They go from adding, adds the numbers from 1 to 4. You can do virtually anything inside of a loop that you want to. You can put if statements inside of loops. You can put loops inside of if statements. You can put loops inside of loops. All right, and nest one loop into another loop. All right. This is the for loop that we just went over last. It's called a counting loop. For, you do your initialization, your test, and your increment or decrement. All right. So all of these, again, can be written. Typically, you can write something like that in there and use any of the loops. All right. Now, I probably closed this already, but no, I didn't. Okay, good. If we were to come in here, let's just use the while loop here. I'm going to copy this and I'm going to put it down at the bottom. Okay. All right. If I were to come in here where we're doing all this stuff, okay, and if I said, as an example, if LCV equal 7, I'm just picking on 7 for whatever reason, break. All right. What that's going to do is it's going to literally, instead of printing out 1 through 10, it'll print out 1 through 7. And it says, oh, it's equal to 7. Break means get the heck out of the loop. Just like it meant get the heck out of the switch statement. All right, so this, like I said, is going to print out then 1, 2, 3, 4, 5, 6, 7. Now, if we move that, so we put it here, if we check right away in the loop, all right, it's never even going to print out 7. It's just going to go print out 1 through 6. All right, so that's if we use a break. Now, on the other hand, if we do this, all right, we're going to have a lot of problems. All right, let me put in the word continue here. Break means get the heck out. Continue means don't do the rest of the loop. Well, this is where we're adding to it. So it's going to come through 1, 2, 3, 4, 5, 6, 7. It'll get to 7 and it'll go back to here. It'll still be 7, so it'll go back to here. It'll still be 7, so it'll go back, and we're putting it into an infinite loop. All right, so we'd want to check for continue after this. All right, something like, whoops, something like that. Okay, so this will print out the numbers 1. Actually, this will print out, let's see, 1, 2, we'll move, we'll move this output line down. All right, but typically what we'd want with a continue is it would then print 1, 2, 3, 4, 5, 6. It would skip 7, 8, 9, 10. So that would be with a continue. So if you want to be able to break out of a loop, you use a break statement. If you want to skip the rest of the code for that iteration of the loop, you use a continue. All right. All right. It is, well, it's actually 11:19. Let's take till 11:30 and then I'll come back and finish this up. We don't have much to do. There's only 4 or 5 pages left. All right. So let's take 10 minutes and then come back and finish up.
All right, it is 11:30. So to quickly finish this up, all right, they talk in here about debugging techniques for programs with loops. All right, we're going to have a whole chapter on debugging later. I think it's chapter 11. But when you look at this right here, when you set certain types of breakpoints, all right, if I put in 10 years, all right, 10 years has 120 months. That's going to go through this 120 times. All right. So if I want to do this, I'm probably not going to set a regular breakpoint and tell it to stop every single time. I'll do a step over and put it, someplace so it goes through, and when it's done, it shows. All right. So all they're saying is when you work with these, it can lead to when you're doing this with debugging, if you don't know what you're doing, it can take a while to debug. All right, finally, they come back in here and they've got this future value form. All right, this is very similar to what we looked at before. All right, but what they're doing in here now, as opposed to earlier, is they're coming in and they're writing it better. All right, what do I mean? They may have even done this before, but now this is going through it once a month. So again, if you're going through and you're figuring out something over 10 years, it's going to go through it 120 times, once for each month during that 10 years. So again, you wouldn't want to put a regular breakpoint right there because it's going to fire 120 times. That really and truly wouldn't make much sense. All right, so I guess they didn't realize we were this close to the end, but I want to say this one more time. This is my plan. All right. By Monday, I'm going to have every test that I've been given will be graded and you will get, you'll be able to go into Inside Rankin and take a look at your grade sheet, and it'll be in there. Now, For those of you who have not turned in any tests yet, all right, you know, you're going to lose points. It's not fair for the people who did their program or their test and turned it in on time. So you're going to lose points. All right. On Monday again, as mentioned, we will go through 4-2. So, for those of you who either want to get a little ahead or want to see what you understand or whatever you want to say, all right, build this interface and see if you can create this program. Then go down and do this one, the factorial. This, I think, is the hardest one out of all of them. Okay, and you actually end up in here using something called recursion, where a routine is going to call itself. All right. This may look hard. It's not. All right. This is a combination of using divides and modulos. I'll just tell you that right off the bat. And this is a little bit harder because you can see it's got a lot of stuff. I'm going to try to do this one. I haven't done this yet, but this weekend I'm going to try to do this one, and I'm going to try to use the switch patterns. So I can say if it's greater than or equal to 11,000 and it's less than or equal to 44,725, then do this type of thing. All right. So I'll see how that works. All right. I'm not going to go into 6. So you can, again, we will go through this on Monday. All right. I will try to have even more problems for you for Tuesday. All right. Then Wednesday we'll have some kind of a pretest, and Thursday we'll have another test. All right. Now, again, I mentioned this before, because if we can keep this up, that'll mean that within 4 or maybe 5 or 6 weeks, we'll be half done with the book. And that's good, because the second half of the book is much more difficult than the first half is. When we get to chapter 8 in a few weeks, we're going to spend a whole week on 8. All right. Then the next week, we'll do 9, 10, and 11. 11 is on debugging. I can't really test you on debugging. All right. So, and it's also a very short chapter. When we get to 12, we'll spend a whole week just on 12. Then another week on 13 and 14, then another week on 15 and 16, then another week on 17 and 18. All right. When we get into the database stuff, which is chapters 19, 20, 21, and 22, I want to teach you 2 ways of doing database operations. Why? Because I think that'll make you even more versatile. All right. As far as what we're working on, we're going to create some kind of a project as a class. All right. There might be times when I say, okay, I've gotten you to this point. Now you finish it up. But there will also be at the end of the semester some kind of a project. If you don't know this, all right, what Rankin is requiring now is at the, sometime halfway into the semester or beyond, every class that you do in a program has to have some kind of a student project in it. And the reason for that project is it's, kind of a culmination or puts together everything you've learned all semester. And these are things that should definitely go into your personal portfolio. So when you're trying to get a job, all right. And I'm going to just show you, I'll just leave you with this. I think I brought it up. This is from, did I bring it here? Do I have it or not here? Let's see. I just want to show you what one of the students who graduated in December, what he did for his final project in his last class. And that is not it. Because it's cool. All right. I mean, he did it. He spent a whole boatload of time on it. His is much better than mine was. I'm sure he spent a lot more time on it. All right. But it shows. All right. And if this takes too long, this will take 30 seconds for this to download. So give me a second here. If it's loaded yet, no, not completely. Is it taking so? All right. I'll try to remember to show it to you next time. I don't want to waste your time and have you have it come up. But I want to show you one of the completed projects that somebody has done. All right. Please, if you get a chance, try to take a look at the examples I said we'll go over on Monday. And finally, if you have not turned in the test, turn in the test. If you have not turned in the homework yet, the homework is due by midnight Sunday evening. All right. If you've got either the test turned in this week or you've got some homework turned in this week or both, you'll be marked present. If you have not turned in a test and you turn in no homework, you're going to be marked absent. All right. Have a nice weekend. I'll see you next Monday. Thanks.